ushered played a huge role, but so did Plan Graphics, helping us to manage that situation. And Jim was sort of in the middle of it. So we've stayed in touch, more or less, but he's really sort of one of the originators of GIS in New York City.
Thank you for the kind introduction, sir.
Welcome.
Yeah, I've been very lucky. I got the chance to work pretty closely with Al for many years, and many of the people at the table. I've probably worked with a third of you, and hope to work with some of the others going forward. There's an awful lot of things that need to get done, a lot of geospatial challenges. Today, I think I only have about 15 minutes, so I'm going to try to zoom through this relatively quick out of respect for your time. But I was telling Dara earlier that I'm happy to discuss any of this, and I wish this was more of a conversation, because I'd like to learn from you as much as you're going to learn from me today, because I know there's a great wealth of knowledge and experience in the room. I hope that future GISMO events will have more presenters. You know, hopefully this gets going and it does stay to be a regular monthly event. So please volunteer what you want to tell us. I'll get started. So quickly, I'm just going to run through what is AI, what is generative AI, what is GeoAI, and then I want to close with some of the ethical and legal issues, which is taking a fair bit of energy for us internally. As we roll out solutions, you have to make sure you're dealing with that. So quickly, as most of you know, artificial intelligence, we're really just trying to use technology to build solutions that can, learn, reason, and make decisions akin to what a human can, and hopefully beyond what a human can, in terms of reach, speed, accuracy. And so we are attempting to replicate our own intelligence. So we look at this using this model, and thank you, Alana, for this. I got a lot of content here from a lot of people for this presentation, so it's really been a team effort. You can see the generative AI, that's where we spend a lot of our time these days. It's really just a subset of deep learning, which is a subset of machine learning, which is a subset of AI. But it's really our most cutting edge projects across the company all are doing generative AI at this point. So many of us are old programmers, and we used to write a lot of custom code. It's a whole paradigm shift. It's a mindset. And so we would focus on, we've got data that we have to manipulate. We have a business process that we have to incorporate. And then we're going to produce a product. Well, with AI and machine learning, the output is the rules. So then you can go back and improve the product. And it's a different way of looking at things. And I can see it in my own company, especially the young people are adopting a lot quicker than the old people. But it's taking time. It's akin to, I remember years ago when I first got involved in agile development. My very first project was for the New York City EDC. And Jim Wen and you taught me agile.
Oh.
And
I thought that was called demanding.
But, basically touching base every day with the new iteration, what incremental change have you made? It was a mindset shift. And there were people that did it very well and people that got left behind. So anyway, what we do in generative AI, it's largely about the model. We stand it up, we run it, we validate it, and then we're retraining it constantly with the results. So generative AI, we're creating new content, we're basing it on patterns, and then we're training the model. We're using deep learning neural networks, and then you're probably familiar, you've probably used all of these, GPT, DALL-E, Canva. Those are just examples, but it's becoming prevalent. I saw a list the other day of a dozen alternatives to ChatGPT. It's just, there's so many options. I'm making this, or preparing this presentation, I really wanted to focus on case studies because as I was talking to Danielle, we wanted to bring it down to where the rubber meets the road. We've all seen a lot of academic presentations about AI. I wanted to communicate what we and others are doing and where the real world benefits are coming. So on-time train arrival, we had worked, this is about 3 years old now. we've been approached by one of the local railroad systems. They're having trouble getting trains there on time. And so we proposed a solution where we read the live REST endpoints from Facebook and Twitter, and we harvested the sentiment. And we didn't call it sentiment at the time, but that's the term now. And we looked for any comment about LIR, our service. We would try to reach out and grab the line or a station identifier, and then we would immediately send that to the dispatchers so they could see quickly in real time where there was dissatisfaction. They knew there was a delay. They could then speed a train up, slow it down, that sort of thing. And they've achieved very high on-time train arrivals ever since. You can see this is about a 4-year span, and they're getting better. There was kind of a very good on-time train arrival during COVID because there weren't a whole lot of passengers. So it's dipped down a little bit since, but they're slowly increasing it over time. And this model has been trained, it's been trained for 3 years now. 5. And it's constantly improving. Another real case example, we were approached by one of the big tolling entities in the area. They were losing over $100 million a year in people that were avoiding to pay the tolls. And so initially, we just had to do a lot of data cleanup. It was not a geospatial solution at all initially. It's cleaning up accounts and trying to look for people that had mismatches and IDs and redundant accounts, dead accounts. That was first pass. Second pass was try to tie that to a vehicle tabularly. And then the third pass, this is underway now, and we're still training this model. We're actually looking for a digital signature of every vehicle that passes through this entity's tolling plazas. And we're matching that to their account in real time to try to increase revenue. And we're slowly, over time, as the model learns, able to reduce the loss of tolls. So that project paid for itself several times over. So GeoAI, we've done historically, I've been involved with more things that are traditional AI, and Geo is more new. So we're seeing a lot of the success coming in object detection, especially in the entities like if you work with Nearmap or Cybermedia, EagleView, they're really employing object detection to speed up their data collection processes. That's really where we're seeing the biggest bang for the buck. We're also deploying at our company a lot of models of prediction and pattern detection. A lot of our early wins are with the Departments of Transportation, both at the state and local levels. Just the volume of transportation data, there's a lot of big data out there between location-based data and connected vehicle. And so just the sheer volume of big data is enabling a lot of use cases. So some real-world GeoAI use cases. We implemented a solution about 3 years ago to do automated accident detection. And that was coming from connected vehicle data that is faster than a phone call or 911 because it's coming real time from your vehicle. Every 3 seconds, all vehicles in the US that have been built in the last 10 years basically send a signal, a packet of data back to their OEM, to Ford or Chevy or Nissan. You can pay to intercept that data. It's anonymized. And you can have latency of 30 seconds or less. So you can see that data live in less than 30 seconds. And so we had one of the thruway authorities in the Southeast, we'd set up a solution for them where we were able to consistently detect hard braking events in that connected vehicle data and consistently beat phone callers to call 911. So they see the value there. We had a transit agency that hired us to look at and try to predict mechanical component failure. Because if you look at rail cars, the truck assemblies, which are the wheels on either end of the car, they're usually sets of 4. Those truck assemblies have to be pre-ordered 3 to 6 months ahead of time. They have historical maintenance records. You know the failure rate. You know based on inspection records what drives failure. So all of this is just input to a model. You throw it in, and we did this for one of the agencies up in New England that basically runs trains in Boston. And we're able now to give them a very good idea of when they need to order the replacement components. That affects the ordering process, their storage. We're trying to reduce their storage so they don't have to have so much on site. And they're better able to plan financially for the next fiscal year and make sure that they've got those ordered and paid for. We're doing a lot of this. We have an energy group at my company, and we're now integrating geospatial, often at a micro level, where we've got IoT sensors on a building or a complex, and we're linking it to the building information system where we can tie it to HVAC and to other systems that can be manually adjusted or automatically adjusted. And we're able to manage energy use and mitigate the energy loss too, because we can also cut work orders, or at least cut a service request to be looked at to see if it needs to be a work order, to provide more insulation, swap out windows, that sort of thing. I have a friend who works for the Forest Service, and he says they're using GeoAI to look at basically whether it's tree stock or just grassland. And they're able to look at the status and the direction of the fire, the weather, work that in. That's just another geospatial layer. They're able to look at the volume of the fuel and the type of the fuel, and then get to the point where they're automatically prioritizing and moving and resupplying those resources. It's better and quicker, more effective, more accurate than human decision making. And this is a recent application I just found out about this week. We had, for the city of Charlotte, we put in an AI system down there where we put IoT sensors on the street around their basketball stadium. And as pedestrian crowds and vehicle crowds grow ahead of every game, we're able to automatically adjust the signal timing in the area to allow extended crossing time for pedestrians. We're able to tell the police in an automated manner where the congestion is so that they can move their forces. All automated. So I just want to run through some other use cases. I got my start in photogrammetry many years ago, which is capture of data. And the advances that we're seeing in photogrammetry are huge. In this one picture, you're seeing basically a 3D, this is a point cloud, but and it also represents, in theory, the orthophoto, the terrain model. You're now able to quickly rasterize that and classify it on the fly very accurately, and then vectorize it and go to wireframe using automated processes. So I used to be a stereo plotter operator. Those people now, we talked about AI pushing people into alternate types of work. This is one of those areas. And I'm very glad I got out of photogrammetry, because automation and GeoAI is having a big, big impact there. This is an example that you gave me, Alana, thank you. This is from USAA. They're doing an insurance company. They're doing automated damage assessments. And we're seeing, I saw many examples actually of automated damage assessments. I haven't been involved in any, but it seems to be now the norm post-hurricane or any event. This is one of the case studies where we're doing live traffic counts. We have a traffic engineering practice, and a large part of their effort has been in just developing not only vehicle counts, but turn counts. Here we're actually getting the accurate turn counts too. So where's the vehicle moving? So this is becoming the norm now. I was told yesterday by our DOT consultants, they just installed a wrong-way driver system using similar technology. It's a combination of cameras and LiDAR, and they can notify state police in less than 2 seconds if a vehicle's headed towards a highway going the wrong way. Another case study here, we did this for a big water utility on the East Coast. We integrated IBM Maximo, ASoft, ASite, which is a construction management system. We integrated Esri in this case. And what this is, behind the scenes, this monitors the settings at the water plant, the water treatment plant. So it's automatically detecting surges in changes in pH, sediment load, temperature, and it's making adjustments on the fly. It's taking the human out of the equation. So it's really, this is a digital twin at this point, and that's the way it's being, that's what it's been deployed as for this utility. And then I want to close with the ethical and legal issues. I've always been a technician at heart, and I'm not very good at reviewing contracts. Sometimes we have to do it. But AI, I think in general, we as a company, we're deploying solutions for customers and for ourselves. We want to honor and respect the privacy considerations. This is a constant learning game. We've been through a lot of this firsthand experience. We built our own internal version of ChatGPT, and we loaded some of our own corporate data so that we can search what we know about our projects and our contracts and our customers and our staff. I use it a lot, like if I need to find somebody who does, for example, like a structural engineer, because I've got a proposal that's mainly technology, but there's a little bit of engineering in it. I can search and find names of people that I can contact. But in doing this is in-house right now. We intend to roll this out to our clients at some point with their data, if they're interested. But we had to make sure, like, in filtering what data is available to our own staff, you have to take out, there's financial considerations, there's there's a lot of PII information in here. We need to make sure there's none of that. So the personally identifiable information. All kinds of legal tech and other reviews had to be performed before we were able to roll this out. And that's my 15 minutes, I think. Thank you very much.